Hi, sir. Good evening. So today I'm going to explain on my lab assignment 2B because previously I've done two times, and both the times I made mistake in the lab assignment 2B, and I got to know what is the mistake based on your video. So I'm going to explain again. I'm doing a correction for basically for my both videos previously. So today I'm going to talk about my second assignment, which is 2B, on variance is to measure contrast of an image. Basically, in this assignment, I'm given with 30 sample of images, basically. You see these images are basically there are some low contrast and high contrast, a mixture of it. And yes, of course, I've I have manually have to lower the contrast by using IMadjust in MATLAB. So since I'm using Octave online version, so I will still be using IMadjust also because it's compatible to MATLAB. So besides that, it's we also I also have done on the t-test function on Microsoft Excel to check the variance for two classes of image. Basically, our classes of image is one is the high and the low contrast. So between that, we're going to find the variance using t-test function. Okay, and in order to do this all these things, I also have to answer a few questions here, which is on objective of the experiment. What is the objective, the design, and what are the steps taken for me to perform this experiment, the t-test part, what is the t-test, and also what is the output of t-test and the conclusion that I got from the experiment. So to actually answer all these questions, I've already answered, and I'm just going to explain to you so that actually make sure that I understand, and as well as you also know that I understand. So I'm going to explain this. Before that, I'm going to show you the code. Okay, actually previously I've already done the code, and the same code is over here. It's just that I am going to It's just that I'm going to run again because I felt that I think there shouldn't be any problem with the code, and therefore I'm just going to run this thing, and I'm going to show you only the t-test part. But I'm just showing the t-test part will not be able for you to see whether it really works or not. So I'm going to start from the first. Okay, I'm going to put this comment, and I'm going to put another comment here because we don't want to see all these things. So I just want to explain from first. Okay, I've already put the comment for the rest of the part. So where we're going to actually see how it works. So basically, as usual, I've already shown you going to show you how do actually I perform. I'm going to actually give you the answer for perform each step. So this part, this question number 3 here is about how to perform each step. I'm going to show you how to perform each step. So the first thing that I'm going to show you is basically I cleared everything before this, and now I'm going to start with image directory. Basically, image directory is actually calling the directory. Since I am not able to use the directory, I'm not able to call the files that I want here. So what I did is I brought all the files into my file section here. I've already uploaded here. So if you see all the images is basically here. So now I'm going to call all the files, and I'm assigning that file list is equal to the directory, whatever inside the directory. And then total files is equals to the file list, number of elements in the file list. So basically later total files will show you how many files that I have basically all over here. So I'm going to save this, and I'm going to run this, and you're going to see. Okay, if you see here, this is called the total file list. Okay, basically there is 34. Why is it 34? It's just because all the files says actually 30 images plus two sub folders. So altogether there'll be 32. And I have two things here, which is on my script, which I have earlier, and I'm using now is assignment 2B. So basically I have two things where these two files will be also readable as 34. And you see that all the file list has names. Okay, we're going to call the file list what is actually file list are. Okay, if you see file list is basically under that got name, folder, date, bytes, is directory, date num, and stat info. Okay, to show you what and each of these means, I'm going to show you that. Okay, so I'm going to show you what is basically what are the things actually I've already you see this now there's a few things, name, bytes, and everything. I'm going to show you what are the things that you can find in directory. Okay, directory is basically to call files or folders or whatever it is from the directory that we call. So basically you see there's name is basically on the file. What are the folders name? Basically it's in character format, and folder is something that there are subfolders that will be inside the location of the file or a folder. So it will show you what folder is that under what folder, and it is also in character based. Besides that, we also have date. Okay, date is basically the modification date. It's in character also. And then we have bytes. Bytes, it's the size of the files in bytes. Basically, how big or how small is the file is. So basically, if it's an image, how big is the image? How small is the image is? Okay, bytes is basically the size. Each directory is basically 1 stands for folder and 0 is a file name. Basically, this is very important where it is a logical class. Why? Because we're going to use that after this, because we only have to call JPG file, because you see there's 34, but we only need 30 files, which are only the images with this JPG file. It's a JPG is a format of an image, because you see JPG, SVG, and PNG are the format of an image. So same goes here. We are using all JPG. JPG file, and these are the files that we're going to put. So if you see, most of all of these are all JPG. So we are using this as our files. So when we are using this as our files, so definitely it has to be that is why we don't want all this is directory, and date name is basically a modification date, which is not important for us. Okay, now since we already know all the file lists and everything, okay, to show you this, we will see about this file list dot name. If you enter, you can see all the names of the files. So whatever files that I've already put it here, you can see all those things here. Okay, each and every file here, and you also can able to see it also included with my myscript file.m all the files and subfolders. Okay, if you see, this is the subfolders. Basically, there are two subfolders, and you're going to see another one, which is file list, which is also very important because later we're going to use this. See, as I told you, everything is zero. Basically, 0 stands for file and 1 stands for folder. So that is why there's two. As I told you, there is two folder here. Okay, we are done with that. Now I'm going to okay, we are done with that, and now what are we going to do is we're going to do one by one. Okay, Control X. I'm going to bring it here. Okay, now we're going to, before we're going to start to read the image, we need to actually call for loop. I've already explained that we call the for loop, and yes, some cut, and I will bring it here this side over. Okay, so if you see, definitely for we have one end, and for if we have another end. Okay, if you see here, why I'm using a loop to read the image is basically, you see, we want to collect all the files, total files. There are 34, but at the same time, we also have to put some condition where we don't want is directory, we don't want folder. Is directory is basically folder. We don't want a folder file. We don't want folder. We only want file. Another one is we use string find. Basically, we're going to find inside the string with the name of JPG, the format JPG, and it has to be in a file name. So if you see here, we have already come up with a file. This is a file name, and in this is called a string. So in the string, we have to find JPG. So that's what we want. Okay, other than that, we don't want, so that we can easily to call the 30 images. So, okay, I think I've done with that. So now what are we going to do? We're going to save this and we're going to run this. So if you see I is equals to 34, so that means altogether there are 34 files. Still they're saying the same thing, but you see somehow later when to read the image, it will be only reading only the images only. So yes, Control X, and then we bring it here. Okay, I'm going to remove this. Okay, now we're going to read the image. Basically, in this reading part, what are we going to do is we're going to call this image directory file list.name. So we're going to call the name file list over here. This thing, the whole thing is going to come under here. And then we're going to name the title it again to the same file name. This is the name. So if you see the pictures will appear, and on top of this, this is the file name. Title is basically always appearing on top of the image. So now what are we going to do now? Since we have done a pause is basically as I told you before, this pause is basically to actually pause, because there are 30 images, which is a lot. So it will pause for 1 second, it will pause and then will appear another image. So pause and then it will appear another image. So basically that is meaning of pause here. I'm going to save this and going to run this. So if you see, there are certain images will not be appearing. Okay, why are they not appearing is just because I'm going to show you later why is it not appearing. Is just because it's very the in terms of the bytes, it's very, as I told you, the size is very big, which is not enough for Octave to actually display them, because the maximum allowed length is 1 million bytes, so which is which our images here is higher than that. Unless if you use MATLAB, then all the images might appear. Okay, we have to wait for all the images to actually appear. Okay, if you see those images are 4474 times 474 times 3 images. Okay, let us see the images. Okay, maybe my video I should put it here. So I will show you the I'm so sorry, not this. Okay, this. Okay, if you see all the images here, this is the last image. If you see all the caption is already here, this is basically the title. Not all the images, certain images appeared, certain images did not, because of because of its resolution and also the file size. Okay, these are the few things that has already appeared, and it's I mean, you can see it. So we have shown you this. Okay, I'm going to pause this. I mean, I'm going to put comment on this, and I'm going to show you the next part, which is to convert to RGB, convert RGB to gray. Control X, and then I bring it here. Okay. Okay, here we are talking about how are we going to because to actually actually see the contrast, we're going to convert to gray. Why are we converting to gray? Is because when you see there's so many colors, it's not easy for us to see the contrast. But unless if it's in the black and white or it's in gray in color, then it's easy for us to see the contrast. So So here we're going to see how are they going to convert RGB to gray, and then now I'm assigning that the one that I'm going to bring it is I'm gray. So I'm gray is equals to RGB2 gray, and IMG. So RGB2 gray is what it means by RGB2 gray. Let us see what is the meaning of RGB2 gray. RGB2 gray. Okay, so if you see RGB2 gray is basically converts the true color, which is the RGB, all the colored RGB, reds, green, blue. That's what it stands for. So that means it's all types of colors to the grayscale image. Grayscale is basically it turns gray. So you're going to see the output later. So I'm going to show you this. Okay, a subplot for 1 to 1 is basically if you see the original image, I title it as for the original image that we are calling from here is IMG, and then a grayscale image, which is the new image IMG gray. So original image will be on the first row, and how do you call this, on the first row on the first row on the how do you call this is it's in the first row, and there's okay there are one row and there'll be two column, and it will be located in the first place. And this one is meaning on the second one, which is grayscale image, it will be in the second place for the first row and the second column. Okay, so this is what it means. So I'm going to show you this. I'm going to save this and I'm going to run this. Okay, we will see that in detail later, and I will explain to you how it looks. So you just have to wait until all the images to appear, because there are 30. That's quite a lot. So we have to wait for some time until all the images could appear. All the image should appear. Okay. So if you see all the for this, you can see all the images. So if you see these images here, okay, you can see all these images here. See, I've named it as original and grayscale. Basically, it will turn to gray without colors. So quickly, I'm just showing you this. So this is the previous one. And then after that, I've made the grayscale. So this is the grayscale version. So you can see two. So this will be the first, it will be in the first row, and there will be two columns here, and it is in the first place, and this will be in the second place. That's what I meant by the subplot there. Okay. Okay, so I'm done with that. Okay, now without wasting time, so I'm just going to lowering contrast, Control X, and then I'm going to move it here, Control V, and then I am not, I'm going to put some comment here. We don't need this, and we just put comment. Okay. Okay, we are done with the comment. Now what are we going to do is we're going to take this comment out, and we're going to show you, I'm going to show you how lowering, this is all basically answering for question number 3, which is how to perform this experiment. So basically the experiment is, this is the way we're going to conduct the experiment. Control, I'm going to save this and I'm going to run this. Okay, okay, this is how I'm going to run this. See, certain images like didn't appear before this are starting to appear now, because see the resolution is becoming very low. And when the resolution becomes low, therefore the size also will become less. So that is why some images could appear now. I see just now. Okay, so we have already with all the image gray and all the image gray poor. So it's here, and then I'm going to show you straight away to the images. So if you see, these are the images. So with those with the high contrast and also the low contrast, let me show you one by one. So these are the images. If you see the high contrast and also the low contrast images. Okay, you can see the difference here. Low contrast is getting the pictures is very like very smooth, and can't see, it's very blur like that. Okay, so okay, so we are done with that. Okay, I just want to explain this part. This is basically low input. Okay, if this is a low input and this is a high input, and then we will have to make it like as we will make it this as the output, and this will be the low output, and this will be high output. So you see, if you see this will be minus with I mean it will add 0.3. Okay, and here will be minusing by 0.3. So and then a high contrast image and low contrast image, that's what we title it. And okay, we are done with that, and then Control X, and then we're going to remove all this thing. We don't want any comment anymore. We are going to the end now, which is on the calculation of variance. Before that, we're going to put this comment here. We don't need any comment here. And then here we're going to talk about the calculation of variance. So calculation of variance is very important, where we have two variants here, and variance for actually the high contrast and the low contrast. High contrast, I name it as IMG gray. So I'm going to call from here the value, and then I'm gray poor, I'm going to call the values from here to here. So basically, and it will be in the first column, this will be in the second column. J is basically looping into 30. There'll be 30 altogether. That is why if you see here, I've also put it here, image variance 0, 30 and 2, 30, there will be 30 images and 2 columns, and J equals to 1. This is basically looping part where J is equals to 1. So each time it goes, it will get into the loop and becomes 1 here. 1 plus 1 is 2. So it will bring up 2, and then 2 comes here back. 2 will be plus 1 will be 3. So it will be looping. Basically, it will loop. Okay, so I've already explained on how to perform. And now the last part here is very important, because variance, we're going to use it for t-test function. So run. Okay, so now you see the variance here. These are the variance, and J is equals to 31 because every time it loops becomes 31, so 30 plus 1 will be 30, so that's what it means there. But if you see, the important one is here is 30 times 2, because we have 30 images and times with 2, which is very important. Image var, so you have to be the spelling has to be the same. So if you see, it is 30 it is 30 times 2, and also if you see, these are the outputs that I have. And if you see, I already brought all. I already brought all the outputs to my Excel. Okay, it takes time to actually open my Excel. Okay, so okay, sorry. Okay, now if you see here, I've already brought my high and low because I name it as high and low. High and low is equivalent to good and bad. Is the same. So there will be high and low, which I've already brought it here. And now, what are we going to do before we actually going into t-test? Before we going to before we going further, what I just want you to know that we have already done how to perform each step. Now we're going to do what is t-test and the output of t-test. Okay, let me explain to you what is the objective, design, and how do I perform and the t-test part. Okay. Okay. So basically, I've answered the first question. The first question here is what is the objective of the experiment? Okay, the first objective here is actually to measure how useful whether variance could be used to measure contrast of an image. Basically, now our objective is already there in the question itself. So the question here is about actually to measure contrast of an image by using variance. So now we're going to see whether is it useful or not to actually to actually measure the contrast, because sometimes if you see if the variance is turned to be different in times, like there is negative and positive, there's so many values which is negative and positive, therefore it is not easy, I mean if it's not so much different and the values are very further, I mean not so it's what it's a negative, and to make sure that, so it's difficult to actually check the variance. So that is what the objective is. The objective is basically to actually check variance, to measure the contrast of an image. And the design part, what is the design? The design is actually given that there is two types of image, I mean there will be one type of image, and inside the one type of image we're actually making it a high contrast one and low contrast with the same identical image. Okay, two same types of image, same okay same types. Okay, okay, two same types of image with different contrast of the same image. So basically you see there's different contrast. Okay, two types of images with different contrast, and it will either high or low, and then we use t-test function, whether it is useful or not. Right? We're going to use that, and we're going to see whether the way using variance, whether variance is useful and different is useful or not. So basically we're going to see that whether the variance is it useful in terms of to check the contrast or is it not. So that is what the design is based on. And then to perform, actually I've explained that in the coding, we have to prepare 30 samples of images with low and high contrast. With using that, we have to measure the variance according to the objective of the question. So if you see, we have given two types of high contrast and low contrast images, and we're going to find whether the low contrast is consistent different or consistent lower than the high contrast. Basically we're going to check with that whether it's consistently lower or it's getting it's higher than the high contrast. So we're going to see the difference actually, which is very important. We're going to see after this. And then for to get step number one, we can go to Google to get the images. Basically we don't have to do that because we have already given the images in various test zip folder. So we got the images from there. We don't have to actually find our own images. Next, we used to assign the image the DRL to call all the images from directory and read the image by using if else function. Basically, I told you we use if else function to actually read the JPEG JPG format images. And yeah, I've already explained the each step. So what are we going to do? How at the end we're going to compute the variance by assigning image variance, and changing for images from RGB to using RGB to gray function to actually change it to grayscale, and then make him IM adjust, as I've already explained here. IM adjust to assigning a low input to 0 and high input to 1, and then low output to 0.3 and high output to 0.7, and make and display the gray poor image. So I've already explained on this. Again, I'm going to say that my objective here is to actually measure how useful weather variance could be used to measure contrast of an image. So this will be my answer. So from here we know that either variance, if it's very, if we're going to see according to the probability, according to the threshold, okay, as we know threshold is given 0.05. If you see it, if we have to see whether the probability is matching or not, whether the difference is there or not. So we're going to see all that by actually going into here. Okay, now we're going to do difference. Okay, for difference we're going to do this. Okay, for difference we're going to do this equals, what are we going to do is A2 minus B2. So if the A2 minus B2 is equal, enter. So you got all the answers here, and then I'm going to do the same thing here for all the points. Okay, if you see it's true, 7222.05 minus 11470.9 is equals to 6051.15. Okay. And if you see all the difference here is very, there are some huge and some it's not huge. Okay, some is big, some is not big, and then you can see the difference here. Okay, so from here we're also going to see on t-test function, t-test. Okay, equals first t. Okay, we're going to use t-test. So our first array, as I've already mentioned, will be A2 double dot and until A31. So if you see these things be until A31, and then comma, it will be array 2. Array 2 is basically B2 double dot and then B31. So if you see, it's also until here. Okay, all is being covered. And yes, we use one tail distribution. I'm going to explain why, and we're going to use the type also. Type is paired. Okay, and then we're going to put enter. Okay, if you see my t-test value is already here, but then I'm just going to make sure that this value is readable. So I'm going to change this to number. Okay, I'm going to make sure that the number can be even, you can see it clearly. So I make it this way. So if you see this is 0.0, this is very small. It's considered to be very small. And that is what 0.00000 until 2666. I mean, not until, basically it's a value, and it's very, very small value when you see there's so many zeros in front. Okay. So from here, I'm going to make the conclusion about the t-test. This is the output of t-test. Okay. Let me answer question number 4 until 5 and 6. As I told you, we use t-test to check the difference. And what is t-test? Okay, t-test is basically a function in Microsoft Excel to check if the variance of the two class of an image is either significantly different from each other or not. Then compare. So we're going to compare with that. Either they're different, either they're significantly different or not. If you see, also that t-test is basically a probability. The output of t-test is actually a probability. See, I've already, it's actually a probability. This is very important. I've already highlighted this. Okay, it's very important because t-test I mean t-test, the output of t-test is basically a probability. I've already explained what are the things that we need to include. The first array is basically the sum of the all values from A2 to A31, and the next array values is from B2 to B31, and the one tail distribution is why are we using one tail distribution instead of two tail distribution? Is because all the values given is positive. If you see here in my values here, all the values are here is all positive. Okay, and if you see that all the difference here is also positive. Okay, so that is why we are using one tail distribution as well as paired. Okay, why is it paired? because the last one is bad because we are comparing the good and the poor because both are from the same image. Okay, basically the image that we're using is the same image and we are comparing between the high and the low contrast. Therefore, we are actually using paired. Basically, they're actually paired. So that is why we are using, because two are same identical image, but we are using to find for different contrast. And then now lastly, we're going to, since the value is too small in exponential, we have to convert to the number to see the value clearly. So basically, yes, I've already done that. So I made it the numbers to be very clear. So this is one very clear number. So from here, we know that the probability is very small. And the threshold given, basically the threshold given is 0.05. Okay, I'm going to interpret the experiment at the end. So that for the interpretation part, I'm just going to find the difference between the high and the low contrast variance values. So we already find the difference. Okay, all the difference is all positive. You see, this for the first image, the high minus the low is 790.03. If you see, there are so many difference, and then from the difference, we know that we can just use one as an example. The difference is considered as to be all positive, and you can see the difference is a small difference. Okay, compared to this, from the high one, the difference is very small. Okay, so and then next, check whether the difference are positive or negative for each pair of the image. So if you see as I told you, all the values for my difference here is all positive. There is no negative sign here. And yes, of course, why? Because all my high and low is also positive. Okay, yes, they are they have consistently difference, and you see that there is difference. I can say some of the difference is quite high. Okay, if you see, there's a few difference is more like around near to 5,490 4,948.67, which is high, and there is difference. So the difference between the high and low is also yes, of course, it's positive. This means the probability that there is consistent difference, also significance difference. Basically, there is consistent difference and as well as significant difference where there is a small difference. Then according to the probability is very low that there is no difference. So according to the probability, this is also highlighted. Okay, as you see, the probability is very low and there is no difference. Okay, and it's unlikely there is no difference. So basically there is no much difference, so the difference is very less. To interpret, we need to check the threshold. Okay, the threshold is basically given 0.05, and the conclusion here, since the probability is low, okay, the probability is low because why I'm saying it's very low is because it's very small. It's very low, it's considered very low, so it's very small. So therefore, there is a significant difference between the variance. Yes, there is also significant difference between the variance. Okay, if you see, the difference is there. And from there, we got to know that we're going to conclude that, hence we conclude that the variance is useful in measuring the contrast of the image. So basically, you see, from there we get to know that variance is useful here because of because the threshold given is 0.05 and the probability is very low, lower than the threshold. So that since 0.05, if you see here, 0.05 is big and near is 0.000000002666, so which is very low. So from here we get to know that variance is very important to check in measuring the contrast of an image. And we always remember that high contrast has high variance high variance, and the low contrast as the low variance. So basically this is my answers for that. I've already interpret the result. So my result here, basically I'm going to retell the result basically is the probability is very low, then there is no difference. When the probability is very low, then there is no difference, there's no much difference. So why I'm saying the probability is very low, because according to the t-test function, it's very low than the threshold. The threshold is 0.05. So therefore I'm saying that it's very low, and if the probability is very low, definitely the difference between the high and the low will be also significant difference. Okay, And conclusion is that since the probability is lower than the threshold, yes. Therefore, there is significant difference between the variance of high and low contrast, yes. Hence, we conclude that the variance is useful in measuring the contrast of an image. So the high contrast has a high variance and the low contrast has a low variance. So this is my interpretation of the results. Basically, my output here is to actually to test the probability. So basically, my t-test function here, I'm once I use the array, the first array, which is a sum of A2 to A3, which is from all the high variance to and the sum of all the second array is the sum of all the low variance, and I use one-third distribution because all positive values, and the last one is paired. Why I use pairing is because we are using from same images. Basically, the contrast is just different. From same images, we are displaying two types of contrast and using that, so that is why it's being paired. And yes, I've also changed it to number format. And yes, what is t-test function? T-test is basically a function in Microsoft Excel, which is a ready function. And it's just that we're going to compare between two class of image. Either it's significantly different or it's not. So we're going to check that. So according after the we find it the probability to compare according to the probability, and you see our probability is very small, so there is a significant difference. So that will be the conclusion part. So this is basically explanation I've already done for according to the code. So that is how I perform. The code is the answer. And is the design of what is the design of the experiment? The design of the experiment is to actually measure two same type of images with different contrasts. So that means when there is different contrast, basically there will be two images lah, different images lah, something like that. And to measure how useful whether the variance could be, that would be the objective. The objective is basically to measure to actually check, or you can say to calculate or to compute whether to actually conclude whether variance is basically useful or not to actually measure the contrast of the image. That's the last part. So the objective, actually I've already satisfied the objective. The answer for the objective is basically the variance is very useful to measure the contrast of image, which I've already concluded here. So this will be the answers. I will submit these answers and also the code and also this video to you today, sir. So thank you so much for listening to me, and I'm done with my lab assignment 2B. Sorry, it's 2B. Okay. Okay, sir. So thank you so much for listening to me again. And yeah, thank you very much. Thank you, sir.